Okay, today we're going to be working on something that you should have learned back in geometry and probably even as far back as middle school math. We're going to be discussing square roots specifically, but we're going to branch that conversation out to deal with radicals as well, so that we can see what the difference is between the two and when we use them and how they're used together and so forth. This is going to be an important pre-lesson, if you will, to material that we're going to use in Chapter 5 as well as in Chapter 6 and 7 and 8 as well. So the skills that you learn in this little review document will serve you well for the entire second semester chapter of Algebra 2. Now, you have received a shortened version of these sets of notes in my class previously probably, and I've extended it to give you a little bit more practice and a little deeper understanding. So let's go ahead and start and take a look at what we're going to be dealing with here. We're going to start off with the understanding of raising of a value to a power. Okay, and so the power is represented by an exponent. So as you can see here, if we have x times x, we can write that as x to the second power. Now, if you recall, in the first semester of Algebra 2, we discussed about raising negative numbers to a power of 2 and how important it was to keep the negative value in parentheses so that you're actually multiplying the negative times each other so that you get a positive value. So that's going to be very important as we go forward here with the radical symbol. Now, if we wanted to reverse this process, so if we wanted to take the squaring process or raising something to a power, the way to undo that, so to speak, is with its corresponding root. Now, since we're strictly dealing with squared terms in Chapter 5 when we're working with quadratic functions, we're going to be working with square roots to undo the power of 2. Now, whenever we use a square root, we are being said to take the inverse property, which, if you recall, just undoes whatever it was, whatever property we were using before. Now, the square root sign is what a lot of you may refer to, is really called a radical sign. Now, this is important to understand the difference here. A radical sign a lot of times looks exactly like a square root sign, but as we're going to find out later in later chapters, that the radical sign actually takes on the number of the root given. So I'm going to give you a couple examples up here. The radical sign is actually the same thing as a square root sign in this regards. It's that 2 is understood to be in that little notch up there. Now, the sign itself, that kind of looks like an old division sign, it is actually called the radical symbol. We will use this radical symbol for all types of roots. So later on you'll see a third root and a fourth root and maybe even a fifth root. And as we said before, whenever we use the radical sign, we're actually using the inverse property, and basically a square root undoes a square, a cube root undoes a cube, and so forth. So we're going to focus mostly on square roots right now, as that's what we're going to be focusing on in Chapter 5. So let's take a look at how a square root actually works and how they cancel out powers with the same degree. As you can see in this little equation, the square root of x squared. Now, it's an understood square root because there's an understood 2 in the little notch. So I rewrote it with the actual root there. So if you see here, we have the root. This is the root, and we have the power, and that is the power or the exponent. And so if the root and the power are the same, they actually cancel each other out. Now, this will actually give us the absolute value of that term. And if you recall from previous lessons, anytime we have the absolute value of a term, we have actually we have the positive and negative version of that particular value. So we can see here that the square root of x is actually equal to plus or minus the square root of x. Now this is going to be important for us to determine in Chapter 5 when we're dealing with quadratics, because we're going to need two answers, and we'll discuss that as we go along. For the purposes of this set of review notes, however, we are only going to focus on the positive version of the root. So if we look at some just basic principles about square roots, we have 5 of them here that you need to be aware of. Negative numbers do not have square roots in the real number system. Now, this is going to be important. We're specifying the real number system here. Later on in Chapter 5, we will actually be dealing with something called an imaginary number, or the complex number system. So, again, we're only focusing on real numbers in this review section and positive values of the square root. So, some basic principles: 0 squared is 0, 1 squared is 1, and you need to just keep those things in mind. Now, we're going to focus on taking the radicals, or the square roots, and putting them in simplest form. And we did a little bit of this whenever we discussed Pythagorean theorem. And in essence, you need to know these 3 rules, if you will, very, very well. So, no perfect square under the radical, no fraction under the radical, and no radicals in the denominator. So let's take a look at each of those instances on their own and see how we would actually reduce those.